Hello everyone, this is Eddie the Magic Monk. Recently one of my subscribers asked me to do a question for him, and I thought that it's a pretty interesting question, and they have agreed that I should share it with all you guys, so here it is. Have a go at it first, and then I will show you how to do it. So here is the question. Matrix A is equal to this. Now, if matrix A plus another matrix X squared is equal to A squared plus 2AX plus X squared, what is matrix X? So what I'm going to do is I'm going to work on the left hand side. Okay, I'm going to work on the left hand side. So the right hand side, I won't touch it just yet. So basically on the right hand side, I'm going to copy all of this down. So by the way, this is a pretty hard question, so I'm assuming that all you guys are really good with matrices already. Otherwise, it's sort of going to be a little bit difficult to figure out. So the right hand side, I'm copying it down as it is. And I'm just going to work on the left hand side, so I'm going to make it A plus X on the left hand side, right? Because that's what squared means. Okay, now if I expand it out using the distributive law, which is allowed with matrices, then you get A squared plus A times X, right? Because we got A squared times A squared plus A times X plus X times A plus X squared on the left, and on the right hand side is just the same thing again, because I'm just copying it down on the right hand side. Right hand side equals right hand side, left hand side equals left hand side. Okay, now I'm going to start doing some crossing out. You can see here on both sides I have A squared and X squared. So I'm going to take that away on both sides. I'm going to take A squared away on both sides. I'm going to take X squared away on both sides. So basically minus A squared on both sides, minus X squared on both sides. And what do I end up with? I end up with AX plus XA on the left, and on the right hand side I end up with 2AX. So that means AX plus XA must equal 2AX. Now still, it sort of does not really let me solve it from there, right? Because I know what A is, but I don't know what X is, and we're trying to find out X. So really I need to know what X equals. So what I'm going to do now is I'm going to multiply both sides by the inverse of X. Right, I'm going to multiply both sides by the inverse of X on the back. So I'm going to put all this in a bracket. I'm going to multiply it by the inverse of X. I'm going to do the same thing on the right hand side. Multiply by the inverse of X. And then you will see that on the right hand side, X times inverse of X becomes the identity. So I can cross it out, change it to I. So it's 2A on the right hand side. Alright, because identity, anything times identity is just equal to itself. And then on the left hand side, I'm going to multiply, I'm going to expand it out using distributive law. So I have AX times inverse of X plus XA X inverse of XA inverse of X. Okay, and then I have X times inverse of X over here, so that cancels down to I. So again, A times I is just A, so I have A plus XA X inverse equals 2A. And now I'm going to move the a. I'm going to minus a on both sides. So I have xa x inverse equals 2a minus a. Right? Because I'm taking a away from both sides. So therefore 2a minus 1a is just a. So on the right hand side it's a. On the left hand side it's xa x inverse. If you guys can think of a shorter way to do this, let me know. Okay, now if I multiply both sides by x, if I multiply both sides by x, then what happens is x inverse times x again turns into I, so I can cross this part out, change it to I. So it becomes xa equals ax. xa equals ax, and now I can substitute a back into this equation. So it's 1, negative 1, 0, 0, 2, 1, 0, 0, 1. So I've copied a down here, and you can see x times a equals a times x. Right, now what does x equal? Well, let's give x a general matrix formula. Let's give it A, B, C, D, E, F, G, H, I. Because we have no idea what it is, so I'm just substituting a lot of general variables in, and I'm going to find out what each one is individually. Okay, so I'm going to substitute x, this general form of x, into both sides. So I have A, B, C, D, E, F, G, H, I, and obviously x on the left is going to equal x on the right, so I'm going to just copy this down again, and I'll substitute the same thing on the right hand side. Okay, now I'm going to multiply it out using matrix multiplication. So I'm going to circle the rows, circle the columns. It's just going to make it a little bit easier when I multiply it out. Oops, there's a 1 there, don't forget that. So then it becomes, actually let's draw a bigger box so we don't miss anything. So first row times first column, so it's just a, and then first row second column becomes negative a plus 2b, and first row third column becomes negative b plus c. Okay, and then I'm going to do the second column, d, and then d times negative 1, so negative d plus 2e, and then second row third column, so negative e plus f, and then third row first column is g, and then negative g plus 2h, and negative h plus I. Okay, so that's the left hand side, and on the right hand side I have the rows circled and the columns circled. So I have 1a minus d, and then I have 1b minus e, and then I have 1c minus f. Okay, and then second row first column, that's 2d minus g, and 2e minus h, 2f minus I. Third row first column, that's g, h, I. Okay, so now we have two 3x3 matrices, and obviously each element is going to equal its corresponding element in the other matrix. So let's just do it one by one. So we have equation 1. Equation 1, I have A equals A minus D. Okay, and then I have What else do I have? I have, let's just write it all out, see what happens. So I have negative a plus 2b equals b minus e, and then I have negative b plus c equals c minus f, and that's that one, and the middle one was that. Okay, then I have d equals 2d minus g. Then I have, it's going to be quite a few, negative d plus 2e equals 2e minus h. And then I have negative e plus f equals 2f minus I. I know this looks really hard at the moment, but later on it's going to be pretty easy. Then I have negative g, oh no, not negative g, just g. G equals g, well that's useless. And then I have negative g plus 2h equals h. And then the last one is negative h plus I equals I. So now we're just going to have to solve these one by one and figure out what each one is. And I don't see a quick way of doing it other than just going at it. There's 9 equations, there's 9 variables. But they should be pretty easy. So let's look at the first one. A equals a minus d. So I'm going to try and do the first one. So let's label it equation 1. A equals a minus d. And if we move the a to the left, move this to the left, then a minus a is equal to negative d. Anything by itself is equal to 0 equals negative d. So d equals 0. Right? Because negative times 0 equals 0. So d must equal 0. So that's equation 1 done. So if d is 0, I'm going to start looking for wherever I have d. So that's going to be over here. Let's call this equation 2. Right, so I've done 1. Now let's do 2. I have d equals 2d minus g. So if d is equal to 0, 0 equals 0 minus g. So what does that mean? That means g is equal to 0 as well. D and g are both 0. It's pretty easy, isn't it? So d is 0, g is 0. Yep. Okay, now let's try another one with g in it. So which one has g in it? This one. Equation 3. So equation 3, I have g is 0, so I have 0 plus 2h equals h. 0 plus 0 equals h minus 2h, so 0 equals negative 1h. Then h must be 0 as well. Ooh, I hope they don't all end up 0. So d is 0, g is 0, h is 0. And now what can I do? Let's do number 4 over here. Right, so negative d plus 2e equals 2e minus h. Let's just scroll to the right. So equation number 4, I've just found out that d is equal to 0 D is equal to 0, H is equal to 0. So then it becomes negative 0 plus 2e equals 2e minus 0. So 2e equals 2e. Well, that's useless. So forget that. Let's not do equation 4 yet. So it doesn't seem like there's any more easy ones. So I'm going to start doing equation 4 here. So I'm going to reorganize equation 4. So I have negative a plus 2b equals b minus e. Alright, that was equation 4. Negative a plus 2b equals b minus e. And then I'm going to move all the b's to one side, so it's b equals... Alright, move the b to the left, so it's 2b minus b equals negative e plus a. So that's equation 4, and I have equation 5. Negative b plus c equals c minus f. And cancel out the c's on both sides, so negative b equals negative f. So that's just saying b equals f. And let's do number 6. So negative d plus 2e equals 2e minus h. Negative d plus 2e equals 2e minus h. And now since there's a 2e on both sides, you can cross them out. So negative d equals negative h. So d equals h. And question 7. So 7 is saying that negative e equals 2f minus f. So that's just f minus I. And then equation 8. Negative h plus I equals I. So do we know anything about h? Yep, h is 0, so 0 plus I equals I. So that's useless. So what have we found? Well, we found that d equals h. Since h equals 0, d is 0 as well. So we found d. And then we have found b is equal to f. Let's just write out everything that we know. So we found that b is equal to f, so therefore I can just write b in both locations. And I found that... what else did we find? So negative h plus I equals I. So since h is equal to 0, I is equal to I. And there's not much more we can do on that. So I'm just going to copy it down here. And c is another one that there's not much more we can do, because negative b plus c equals c minus f. So don't think there's anything we could do with c, unfortunately. So let's just put What is F? So if we were going to find A with respect to B and E, actually I'm just going to keep A there, and I'm going to get E with respect to A and B. So negative A plus B equals negative E, so E must equal to A minus B. So E is A minus B, and the only thing left is C, and unfortunately I can't see C being anything that we can figure out, so it'll have to be another variable. I'm just gonna put C here. Okay, so this is my matrix. Okay, the general form of matrix X. Right, and basically you can substitute any real number you want into these A, B, and C, and then you just have to and I, and you just have to make sure these two middle numbers come from A minus B and B from the second element. So an example of that would be wait, one more thing. Negative E equals F minus I. So if I rearrange it to make I the subject, I then becomes negative I becomes negative E minus F, so I becomes E plus F. So instead of writing I down here, I can write E plus F, so that is A minus B plus B, so that's just A. Okay, so that just turns out pretty good. So I have three variables only, A, B, and C. So you can let A, B, and C be any real number. I'm just going to let A equal 5, B equal 3, C equal 2. So then you have the matrix 5, 3, 2, 0, 2, 3, 0, 0, 5. And then if you substitute all these numbers into where A is, okay, into where A is, or into where X is, then X times A should give you A times X. Let's now test it in GeoGebra. So in GeoGebra, I'm going to put in this matrix first. Matrix A equals, so matrix A equals braces 1, negative 1, 0, 0, 2, negative 1, 0, 0, 1. That's matrix A. And matrix X, I'm going to type in the matrix that I have just made up, which is, after all this working out, 532023005. So matrix X is 532 023 005. Okay, now let's try A times X. A times X is matrix 1, and now let's try X times A. And it should give me the same matrix. Yes, it has given me the same matrix. And that shows that this is the answer. Okay, this is the final answer. Matrix X. So the question was, find all matrices X so the following is true. So therefore, my answer is over here. Right, this is matrix X. Okay, sorry for confusing you guys. It was a pretty hard question. I'll see you guys next time.